Okay, we're back as promised. Well, I'm back as promised. Let's talk a little bit more about these fractions, right? Um, I promised that I was going to get into adding fractions, but I wanted to stress a little bit more on the importance of multiplication when dealing with variables, right? We've done definite numbers, right? We're dealing with things like 1/2. I don't know why I always go there. Times 3 over 5, right? Even using some mixed numbers like 1 and 2, 8, no, 2/5, right? And converting these and then even dividing by a mixed number. But everything's been a definite whole number, right? Um, so, and we've had some rules in place. We talked about dividing by a fraction is multiplying by its reciprocal. And we also talked about and spoke a little bit about how we convert mixed numbers, right? And gave a little bit complimented them with a little bit of terminology such as improper fractions, proper fractions, whatnot. But let's now get into the realm of introducing variables, right? So, for instance, because this is what I've been stressing in class a little bit more and getting to, right? So if I have x squared divided by x squared, we know a number divided by itself equals to 1, right? As long as, well, yeah, we'll just say that for now. Equals to 1, right? We are, let's even talk about 2 divided by 2 equals to 1. -2 divided by -2, or -5 divided, doesn't have to be 2, and anything, right? A number divided by a over a equals to 1, right? Good. Not hard to not a hard concept to grasp, right? But I like to prove it because we start introducing the rules of exponents when we prove this thing. Let me see, where's my pointer? There it goes. Okay, so x squared over x squared. Now, in class I mentioned the rules of exponents, right? There's a few rules at hand, and I want you guys to keep these handy. Rules of exponents. Now, the reason why I introduce these now is because they're fundamental when multiplying and dividing fractions, right? And even taking even exponentials and everything, right? So, not fractions, but variables, right? Anything with exponents, right? So when we have anything with exponents, it's multiplying and dividing. So a to the n times, these are just general formulas, a to the m, right? Same base here, a is same, right? Just different exponents, or it can be the same exponent, doesn't matter, right? Will equal to, let's put equal sign, a to the n plus m. So anytime you're multiplying anything with the same base and that has exponents, you simply add the exponents. If you divide, right, then take that. Remember I said the counterpart to addition is subtraction, and minus m, right? If you take a to the n and raise it to the m, well, now we're multiplying a and n and m. So far we've added, we subtracted. Now we're going to multiply the two factors, right? And if you wanted to, since we multiplied these going in, right? If you wanted to kind of, well, no, I'll get into this later. Not here. What else would I do? Oh, another thing. A, B. So these are two different variables. Say two different bases, right? Or two different values, right? To the m, or say n. Both of them get raised to the n, right? Cool. So that helps guide us along a little bit. So let's do this, right? Ooh, not good. Not good. Okay, so check it out. Because I said they're the same base, or because you can see that they're the same base, right? And that they're being divided and they both have exponents. Well, the rule states, say this is number 1, number 2, number 3, número 3, and number 4, right? Rule number 2 states you subtract them. So, x 2 minus 2, so you just simply write the base ones. And now you're kind of interplaying between the exponents. And we subtract them, right? So what's 2 minus 2, you guys? 0. Okay, so x 0 and x or anything to 0 is simply 1. And that's why we have that a number divided by itself equals to 1, right? Cool. Now, let's put this into play a little bit more, right? What if I have, say, 2x over 3 over x squared, right? Let's start with that. Equal sign. I always put arrows, but equal sign, right? Well, remember, we're now utilizing that concept again, or that rule. You divide by a fraction, or you multiply its reciprocal. So I think again, the biggest issue here is identifying where the fraction is, and we can say that's we can say confidently that it's 3 over x squared, right? So 2x. So we're going to multiply the reciprocal of 3 over x squared, which is simply x squared divided by 3. We can think of this as 2 over 1, right? Again, 1 is assumed. So, or it's yeah, it's assumed, I guess you can say. So now we have, I'm going to write this as one entire fraction, 2x times x squared. Ah, God, I'm so sloppy. Divided by 3, right? This, not bad. It's this guy that starts to become a little bit more difficult. It's the x and x squared. Well, we said if we, according to rule number 1, right? If we multiply anything with the same base raised to an exponent, right? Just add the exponents. Let's do that. Oh, by the way, anything raised to the 1 is itself. That's why 1 is assumed here. So you would have 2x, the first, right, plus 2, right, divided by 3. That's showing your work. 2x cubed over 3. And that is your answer for that, right? Right. Let's increase the difficulty a little bit in this. Okay. Say, give me a second, you guys. I gotta respond to something. Let me put it on pause. Un momento, por favor. Alright, sorry, you guys. So, check it out. Now we have, I forgot where I was at. What seemed like a glitch to you was more or less like 5 minutes for me. So, I think we're just getting to this point right here. Let me finish it. Oh, there it goes. That's why. Ah, mira. Okay, look it. Alright, so we have the answer here. Now, if we take and change it up a little bit, let's increase the difficulty level. What's going on here? Jeez. Things are disappearing on me and then reappearing. Okay, right. Let's increase the difficulty. Say if we were to divide, say 2x cubed divided by 3 times 5x divided by 8x squared, right? Immediately you can see that we're dividing here, so we can go ahead and what? Actually, I want to make this, let's make this the fourth, right? We're dividing here, right? So we can immediately say, well, same base, different exponents, right? Don't matter, n, m, subtract the exponents, and we can bypass the step of having to write it down, or I'll do that for you guys. So we can keep 2x to the cube, or 2x cubed, consistent for now, and just handle these guys right here, right? So we have 5, 8, and then we have, along with it, x to the fourth minus square 2. 2/3 x cubed times, what is it? 5, 8 x squared, right? Let's figure this out now. So we have 1/4, right? Here. Reduces. So you can handle the actual values, these guys. Definite values, the whole number. You can handle the numbers like you would in any normal fraction. And then we can see now here that we have, let me see, this can be 5 over 12 would be, let me see, that takes care of that. Now you have x cubed times x squared. And since we're now multiplying them, we simply just add them. Add the exponents according to rule number 1, which is x to the 5th. Voila. Magnifico. Right. Wow, I don't know what that was. Sloppy, that's what that was. Right? I'm trying to draw a box. Alright, cool. Now, let's just play around with this a little bit more. Right? If I have, let's say, oh no, I keep just trying with 2. 3x to the 5th. Let's make it a whole number. 1x squared divided by 5, right? Times 2x to the 3rd over, let's give it 3. Let's leave it there. Alright, now we have a mixed number, right? Don't matter. The fact that we introduced a variable does not change the fact that it's a mixed number. It could be improper or proper, depends on what x is. But we do know that we can convert this guy, right? With the same rule. So let's go ahead and rewrite this with the converted mixed number, or the mixed number converted. Changing nothing else. 5 times 1, 5 plus x squared, right? So 5 plus x squared divided by 5. And you're going to multiply that by 2x cubed over 3. Right? Nothing has changed except the fact that we converted this. And as we've done in the past, take the reciprocal. 5 plus x squared. I'm losing my mind, you guys. Right. Okay. Now we're multiplying. Consider that over 1. Why not? Fraction over times a fraction, or multiplying this times that times this times this, right? I wish I had a cursor you guys can see on here. I'm still learning to work with this. Okay, let's do it. I'm going to go to multiply 3 times 5, which is 15 times 2, right? Simply 30, right? Oh wait, this 3 cancels out, right? So it's 5 times 2 is 10, right? So I'll multiply those two, 10. I'm going to write x to the 5th times x cubed, and then we're simply left with 5 plus x squared in the denominator. Right? Let's go ahead and finish this off. Simplify the x. So remember, we're multiply anything with the same base, different exponents, we're multiplying. So what do? We just add the exponents. So 10x to the 5th plus 5 plus 3, right? Simply 8. So 5 plus 3 equals 8, divided by 5 plus x squared. Not bad, right? Hmm. Just realize that you cannot reduce here. This will be your answer. The reason is because, well, yeah, you can't find any common factors. You would have to factor something out completely um, from each of these on the top and the bottom, right, to be able to reduce. But there's something we can factor out that's common. So you have to keep this as is, and this is your answer right here, as you see it. Oh, man, dude, I apologize for the sloppiness. I am bad news bears. Good, it's good, good movie in the past. The remake sucked, but hey, what can you say? Okay, let's see if we have time for one more. No, I don't know if I want to do that. Just risk it. Okay, let's take something else, right? So say 2. Oh God, I always start with 2. What's going on with me? 5 x squared divided by 3x over 2 times 1 and 3/4, right? All right. Again, mixed number. No, only one mixed number. So go ahead and convert that baby, right? And at the same time, let's take the reciprocal of this guy here and multiply by it, right? Times, and then we need the reciprocal. So this, all of this, is this here. This we still need to convert. So 4 times 1, 4 plus 3, 7, right? 7 over 4. So we're multiplying these two guys, right? Now, notice again we have x squared divided by x. Simply, what do? You subtract the exponents. So x squared, think of this as again over 1. X squared divided by x, or 2 minus 1, is simply 1. Or x goes into x squared once, right? And then we have times 2. I should have written that as 10x. I'm making this one quick. Over 3 times 7 over 4. And then can we reduce? Well, this is 2. And then we have 5, right? So 7 times 5, 35. X. 2, 6, right? I don't think there's anything else we can reduce. No. That's equal to. So this is your answer, you guys. All right. I think that takes care of that. Take care.